So today we're finally getting into periodic table terminology now that we've gone over the PhET simulation with the subatomic particles. So remembering the PhET simulation that you all did yesterday, um, what is the net charge of the nucleus? Write this in your handouts. You can pause me, and then once you're ready to move on, go ahead and unpause me. Um, So the net charge of the nucleus is positive. Hopefully all of you guys see this, right? Here are your neutral neutrons in gray. They don't have any net charge. And the protons, which are orange, are positive. So overall, the charge of the nucleus is positive, which is balanced out by the negative charge from the electrons. So you can see here 2 protons is plus 2, 2 electrons is minus 2, so plus 2 minus 2 equals 2, 0. So this atom is neutral. So remembering that on your reference table, pages 9 to 11 at the top of the Google Classroom, the atomic number is the number of protons in the nucleus of an atom, and it is what identifies what an atom is. If the atomic number changes, all right, if this atomic number changes, then the atom changes. If the atomic number doesn't change, aka the number of protons doesn't change, the atom doesn't change. And that's really important to remember because it doesn't matter if the number of neutrons or electrons changes. It only matters if the number of protons change. All right, so there can be some tricky Regents questions with regard to this. So with that being said, in your handouts, we'll check this tomorrow. Use your periodic table on page 9 of your reference tables and answer what are the atomic numbers, or in another way, how many protons are in these elements. And you see over here that we gave you the answer for carbon. The atomic number of carbon is 6. So it's 6 on the periodic table, and it also has 6 protons. All right, so finish the rest for oxygen, chlorine, and magnesium. Next, we want to talk about atomic mass. Obviously, atomic mass, atoms are made out of more than just protons, right? They're usually made out of neutrons and electrons, even though electrons are so tiny that their mass is negligible in the grand scheme of things. And different isotopes of atoms weigh a different amount, right? And isotopes, remember, is just the definition for an atom with the same number of protons or the same atomic number, but different number of neutrons. So it's like different variants upon the same atom. So here's a helium atom, 2 protons, everyone sees that. So its atomic number is 2. But this helium atom has only 1 neutron. Whereas over here, this helium atom has 2 neutrons. So this would have an atomic mass about 3, this helium isotope, and this helium isotope would have an atomic mass about 4. And what we mean by weighted average is it's a mathematical concept. So this type of helium doesn't occur very often in nature, whereas this type of helium is much more common in nature, right? So let's say 99% of all helium has 2 protons and 2 neutrons, whereas only 1% of helium has 2 protons and only 1 neutron. And so the weighted average of all of the helium in all of the world, if you added up all of the isotopes and divided it by the number of helium atoms, would be like 3.99 something, right? So that's what we mean by weighted average. So with that being said, that's why we have these like weird decimal points after the atomic mass, okay? So look at our example that we have here with carbon, where the atomic mass is located on your periodic table, and use this reference image to determine the atomic masses of carbon, oxygen, chlorine, and magnesium. Record them in your handout, and we will go over the answers tomorrow. And then the next thing that we would like to introduce you guys to is mass number, which is basically it's different from atomic mass because atomic mass is talking about all of the isotopes that exist on Earth, right, or in the universe. whereas the mass number is talking about the specific atom. Like if we put this helium atom in front of you and asked you what its mass number was, then you would answer the number of protons and neutrons in that particular helium atom. This atom doesn't matter about any other helium atom, okay? So you'd count, I have 2 protons, 1 neutron. 2 plus 1 is 3, so the mass number of this helium atom would be 3. A good rule of thumb when you want to determine the mass number is just get rid of the decimal point, right? So in this particular example, the atomic mass is 12, not 12.011, just 12, because for most carbon atoms, they have 6 protons and 6 neutrons. There is another isotope of carbon called carbon 14, where its atomic mass is actually 14, right? So on your periodic table or using your periodic table, determine the mass numbers given by your table of carbon, oxygen, chlorine, and magnesium in their most common isotopic forms. So we remember that isotopes are an atom of the same element with different number of neutrons. So both helium atoms have 2 protons, so they're both helium, right? If they had any other number of protons, it would be a different atom altogether. But this helium atom has 1 neutron, this helium atom has 2 neutrons, right? And so when we're talking about notation, all right, this is something we'll go over in class tomorrow. As I mentioned, here is your carbon 14. Here's the number of protons, number of neutrons. You have different isotopes of the same atom. Okay, so I will see you guys tomorrow. Make sure to have mastered the vocabulary that we've taught you, isotope, mass number, all right, atomic mass, and atomic number. And I'll see you guys tomorrow.